All right, so what we're looking at right here is the igneous rock chart. Now, remember when we were talking about the classification of igneous rocks, we looked at its texture, and I told you that I would give you the proper term, but also what it meant. Phaneritic is coarse grain. Aphanitic is fine grain. We'll also look at vesicular, or holy Swiss cheese is vesicular, and also glassy texture. So on this side we have texture. Across the top we have mineral content. And remember, if you're a felsic igneous rock, you mostly contain light colored silicic igneous minerals. Okay, if you're a mafic igneous rock, you mainly contain those dark, denser, higher temperature, iron and magnesium rich igneous minerals. And if you're intermediate, you have a pretty much equal mixture of both. Now, I boxed in the main 6-pack here, and these are pretty important. And then we'll also look at some of these ones here on the periphery. Now, I also have some examples to show you. Now, when you see a chart like this, and you guys will, there'll be one like this on the exam. What I always do, because I make these up, and so they can flip and flop just kind of depending on how I'm feeling. I don't mean to be tricky. I always look for what I know, and pretty much everybody knows about granite. Okay, granite countertops. Now, granite is felsic or silicic, mainly made up of light-colored minerals and coarse grain. So as soon as I put in granite, you know, I kind of have myself anchored. Now, here's a typical granite. It's a pink granite. Pink is that potassium feldspar mineral. It's also got muscovite mica, biotite mica, and some kind of smoky quartz in there. Okay, so that would go right here. All right, now if that granite were to have erupted out at the Earth's surface, it would be fine grain, and that rock is rhyolite. Okay, and we will talk more about rhyolite because these type of volcanoes are really dangerous. And I grabbed a pink copy of rhyolite, or a pink piece of rhyolite. Again, it's pink because it's got those very small K-spar, potassium feldspar. But if I would zoom in on this quite a bit, it would probably look pretty similar. These guys are chemically the same. The textural difference is that the granite cooled slowly beneath the Earth's surface, and this rhyolite erupted out at the Earth's surface and cooled rapidly. But chemically, they're the same. All right, well, let's head to the intermediate. If we've got coarse grain intermediate, this is going to be equal parts salt and pepper, and my example is diorite. Okay, diorite has equal parts black and equal parts light colored minerals. Okay, and if that were to erupt out at the Earth's surface, I would have that extrusive equivalent of andesite. Okay, it was named after the Andes volcanic mountains, which are igneous, or volcanic mountains that are made up of this gray andesitic material. Again, chemically the same. This just cooled slowly. This cooled rapidly. All right, let's go mafic. Here is some Gilardi Street gabbro that I keep talking about. Lots of olivine. Olivine is olive green with some augite, the black green type mineral. Little bit of the white mineral, calcium plagioclase feldspar. So this is Gilardi Street gabbro. Okay, and when that erupts out at the Earth's surface to make a fine grain volcanic rock, it's the most common igneous rock on the Earth's surface, or basalt. It lines the sea floor, it makes up the big island of Hawaii and the other Hawaiian islands too, and it tops Table Mountain in Oroville. All right, let's come down here. Well, first of all, my ultramafics, I talk about them in the slide on iTunes, in the slides set on iTunes University. Peridotite is ultramafic, coarse grain, mostly olivine, and its extrusive equivalent was comatite, something that we don't have much of left on the Earth because it was formed like 4 billion years ago. All right, vesicular. Vesicular means holy. Right here, you guys could use this to scrub the calluses off your feet. This is pumice. Okay, and that would be my mainly light-colored minerals making that up. And right here, I couldn't find a black piece, but I found a red piece of basalt with bad gas, which is scoria. Okay, it was originally black, except it was probably in a wet environment, and so oxidation or rusting occurred pretty quickly. All right, and down here The only glassy one that we do have is obsidian. Now remember, if this obsidian had bad gas, it would be this pumice. And there's lots of places where you can find a pumice and obsidian kind of fingered together. And actually we have a little bit of obsidian kind of in here, but I have some better samples. So they are chemically the same. This is that exception to the light versus dark rule. It's dark because light enters, but it doesn't get out because of the chaos. There's no regular repeating internal structure. All right, so we've got our igneous rock classification. So the main 6-pack is here. This makes it the 9-pack. It used to be the 12-pack, so drink a few here. So we've got our granite, diorite, and gabbro. And literally, when I come across these in lab, I lay them out: light, intermediate, dark. Okay. Then I've got my rhyolite, andesite, and basalt. Again, there's dark, there's gray, and there's pink. So light, intermediate, and dark. Okay, my pumice and my scoria, felsic, mafic. It's just red because of oxidation. And then the exception to the rule. This is actually felsic. It's mainly made out of quartz. And you can tell because the quartz breaks with that circular break. And that has that conchoidal fracture.